So before the break, we saw some very nice things which Python allows us to do just in one line of the code, basically, using this paradigm of functional programming. Now, if you are excited about this whole concept of doing things in just one line of code, and you should be, because Python really allows us to do quite awesome things just in one line, let's see how we can take this idea even further, and we'll see something that is called the list or dict or set comprehension, which is very often is even a more useful syntax than defining function and using all kinds of functional programming, using the map and filter and the things we saw before the break. So let's begin again with an example. So suppose now we want to, okay, so this is an example we saw before the break. So we have the range of all the numbers between 0 to 9, and we want to calculate the square of them, getting a list with the squares of these numbers. So using the map function, which we saw earlier, this would look something like that. We would need to define this lambda function and provide the list that we want to work on and convert everything to a list. And we can do it with just one line of code, but the downside is that it might be a little bit hard to follow. You can see all of those parentheses here, and it can take a while to once you read it, to figure out exactly what it does and the purpose of each piece here in the puzzle. Now, it turns out there is an even simpler way to do that, which is called the list comprehension syntax. And the syntax is actually nothing more than some combination of a list definition with a for loop. So you can see, like when defining a list, I provide these square brackets, meaning that I want to create a new list. But within this list, what I have, instead of specifying the elements with a comma separation, I actually create this kind of a for loop. And like a for loop, I have for something, some variable name within some collection of elements. But then instead of putting this colon and breaking a line and creating the body of the for, instead I put the body of the for loop on the left side of this syntax. And what I end up is with some expression for every x in the range of 10. And this will actually give me the same result. It will give me the expression that I calculate for each one of the elements within this sequence. So it will end up giving me whatever map gave me, just without needing to specify an explicit function. Rather, I will just write the expression in line. Any questions about this syntax? So using this list comprehension, I can do pretty much what map allows me to do, and most of the time even in a simpler way. Now it turns out it can replace not only the map function, it can also replace the filter function. So let's see how that works. So let's go back to the example we had earlier. We have a list of numbers, and we want to filter just the positive ones. So using the filter function, we will have to specify this lambda function, filtering the positive numbers, and specify the list, and then converting everything to a list. We can also do it, it turns out, using the list comprehension syntax. Here what we have is just iterating over the elements as they are. So the expression is nothing more than x itself. So if it were just this part, this would actually do nothing. It would just be for each x in my list, take x again and do nothing. But then what I have in the end, I have this if statement that allows me to specify some condition, that I want to take elements only if this condition is met. And this is actually the same as using the filter function. It basically filters out only the elements that meet this condition, and I get the same results. Now, it can also combine the two of them together. Now, if I want both to filter the positive numbers and to calculate their square, If I wanted to use the old filter map syntax, you can see it ended up as quite complicated, very nested code with many parentheses. So I need to have this filter with the lambda function, and then this filter is the input for a map function with this lambda function, and I need to plug everything in place in order to do it using functional programming. But using the list comprehension, it's much simpler because the syntax is just much more clear. You can actually see what's going on here. So I have a for loop for x in my list. Only if x is greater than 0, then should I take the square of x. And this gives me the same result. Questions? Okay, let's see another example. So if you remember in the previous exercise, we had a DNA sequence and we wanted to break it into triplets, into codons. Now with list comprehension, we can do it quite easily. What we need to do is just to iterate through all the indices from 0 to the length of the sequence with jumps of 3. And then for each such index, we slice our original string between I to I plus 3. And we basically get a list of all the codons. So that was list comprehension, which allows me to create lists using for loops all within one line. Now using the exact same concept, Python also allows us to create other types like dictionaries. So this is, instead of being called the list comprehension, it's called the Dict comprehension, but the idea is very much the same. So suppose I have a list of strings, and I want to create a dictionary that maps each of those strings into its index plus 1, say. So using a Dict comprehension, all I need to do is to specify a dictionary, using these curly brackets. And then, just like a list comprehension, I specify a for loop. In this case, I use the enumerate of numbers to iterate both the indices and the actual elements within this list. And then I take each element, and using this colon syntax, I map it to the index plus 1, and I get the dictionary that I wanted. Okay, so let's see a more practical example. So suppose I have a DNA sequence, and I want to calculate the frequency of each nucleotide. If I just want to count each nucleotide, I can just use the counter, which again we saw in the previous lesson. This will give us a dictionary-like object that has the count of each nucleotide within the DNA sequence. But now we want the frequency, not the count. We want to normalize it such that all the values would sum up to 1. So we want the percentage of each of the 4 nucleotides. Using a Dict comprehension, we can do it in just one line. We use the anti-counts that we created. We iterate through each items, and we take the nucleotide and count of each nucleotide. And then in our Dict comprehension, we map the nucleotide to the count divided by the length of the DNA sequence. So this way we normalize it, and we end up with the frequency of each of the 4 nucleotides. So we had a list comprehension, and we had a Dict comprehension, and pretty much in the same way we can have a set comprehension, which again just gives us a set. So let's see an example. So using a list comprehension, I can calculate the remaining parts of some numbers divided by 6. So the modulus, use the modulus operator to get the modulus 6 of all the numbers between 5 to 20 with jumps of 2. So this is a list comprehension, so it will just give us all the values. But if instead of regular square brackets, I give these curly brackets, then now Python knows that it's actually a set, not a list, so we get a set where the order is not important, and we do not have redundancy, and we can get just all the values that this calculation would give us. Now, how does Python know that this is a set and not a dictionary?
Because it has
Exactly, it has just one value and without a colon. If we put a colon and mapped it to something, say if we did something like that, then we would get a dictionary. And finally, you can also use this comprehension syntax to, you can also use it on nested objects. So you can take a nested list of a list of lists within a list, and you can flatten it out and get just one list of numbers. And the way you do that, the syntax is, first you have a for loop for the outer lists. So just for any sublist in the nested list, this will give you the sublist, and then afterwards, right to the right of it, you put another for loop which iterates through each of the sub-elements. And for I in the sublist, and then what you take out is just the I. And of course, if you wanted to make some expression here, you could do that just as well. And you can also add some condition either on the I's or on the sublist. It doesn't matter. For example, you can take only sublist, say, with at least 3 elements. And yeah, and you can basically do whatever you want.